Throughout the age of video games, many have questioned whether or not the keyboard and mouse is actually the optimal setup for enjoyment. This fact is proven by different setups like the Razer Hydra, various joysticks, steering wheels for driving games, the Mayo, etc. We propose to create a special control method for an isolated case in order to perhaps improve enjoyment. In other words, we want to craft a controller that will excel in a specific type of game. We want to simulate the controls of a World War II flak cannon. This means having two crank controls to move the vertical and horizontal axes of the cannon. By using these controls, the user may feel more in tune with the game, and it may be more enjoyable to shoot down airplanes if you use a control method similar to the real deal. Okay, so we're gonna present our product for you and show you how it works in Unity over here. But first I'd like to just show you, just as the video did a moment ago, the various prototypes that we made just to present all the iterations that we actually went through. We started out making some very, very crude gears because we actually didn't know what we were doing. And obviously this doesn't work very well. So this was try one and it horribly failed. So basically, we went on to study how the math worked behind the scenes, trying to figure out where the entry point should be and how it related to its center holes and so forth. All this is previously explained in the video or will be explained in the documentation along with this project delivery. So basically these are some of the iterations that we have on the gears, finally ending up with this one that fits, well, okay, snugly onto this one over here with a slightly smaller hole, so I can't really push it all the way on there. The way we made the fittings for the box was using a slightly larger PVC pipe and a PVC pipe here, just to have them function kind of like ball bearings. There are some small issues though. Even though the smaller pipe fits snugly in here, it also wiggles a little bit because it has like 0.5 millimeter of room to budge around. This could have been fixed by adding some foil or something around the actual PVC pipe, but this was not something that we thought about during the production procedure. One more quick thing I'll show you before I start everything else over here is this. This is the prototype for a handle, which you can see here and here. And it basically has a bigger pipe here for, again, the ball bearings, so that you can actually rotate it. And then it has a hole for the PVC in the middle in order for it to be able to turn properly and not skew the angle in here. Okay, so the actual box. We have two handles and a button. This handle controls the y-axis. This handle controls the x-axis, or the horizontal and the vertical axes of the cannon that you see over here in a moment. Then we have a button here, which is a simple button with a fitting in here, and then a spring in order to make it a little bit tactile. Originally we wanted to have a lever, but the lever could not be a part of our final design due to time restrictions, so we made this button instead. And it works just fine. Out the side, for the hole that we made the lever, we instead fit with our wiring, so that it can fit snugly into the computer here. Just to really quickly lift up here, you can see there's a lot of stuff. We're going to show this later, because we don't want to disrupt anything for the actual presentation over here. So let me just move this out of the way. Okay, so let's start Unity. When I turn the horizontal handle, it'll rotate a little bit. There are some things about the sensor that we're using though. We're using a 12-turn 360-degree rotary encoder, which sometimes glitches a little bit. As you can see here, it goes a little bit back and forth because it has a hard time figuring out which way it's actually going. Even after adding a pull-down resistor to the edges of it, or the two other pins, it didn't really help a lot. So what we've been doing is trying to create a median filter system that will remove these small errors that are sometimes. As you can see here, we have the y-axis moving, and right now it's a little bit glitchy over here because the system was originally made by using buttons on the computer, so that needs to be changed. But as you can see, it clearly works with the interface here, so the rest is basically just programming that needs to be finished. And as I said before, you can fire with the button over here. And that's basically what is in the game at the moment when we're finished, because we want to finish this awesome, really cool thing. It's going to have airplanes and not the space theme in the background. It's just something for the fun of us. And then you're going to be able to fire around here. We have some issues with the weight of the box, because when we move this around, sometimes you end up lifting the box, so we need to figure out the weight with this. But that is, I mean, this is a prototype, so we can't really have everything finished. And since we used medium density fiberboard for the entire box and PVC, it doesn't really have a lot of weight. I think it weighs half a kilo to a kilo, so that's about it. Okay, so let's look at the insides. Okay, so let's have a look on the inside here. We just plugged it out in order to pick off this lid. Basically, this lid has a hole for the button, and the button, of course, has a wire for the V-in, the voltage in, and a part here for a pull-down resistor. There's a resistor in here, and then a cable out before the resistor in order to bridge the current into the Arduino that we have down here. Now this may look like a mess, but it's actually not. I just need to get this out and pull this wire out and out there. And then we have everything snugly right here. So now that's picked off, and we have these two sides here. This one over here controls all the voltage, all the inputs, and this controls all the voltage, along with this one over here for the second ground pin that is on the Arduino board. This is an Arduino Uno, by the way. Okay, so this is all just put down onto a whole board, whole cord på dansk. And then we have our two rotary encoders wired down here. Also put into PVC pipes and then into some specially fit gears down here. If I turn this around, you'll be able to see what's going on. And this basically just turns everything so that the system can register it through the digital pins in and out as a high and low input system. The same thing works over here. Now this may look a little bit weird with the random gear over here, but the thing is, we had actually made a system for dividing the rotary speed, the rounds per minute, by 1/6 because we didn't want to overload the sensor. However, we found that this division was so large that it created a lot of latency in the system. So we made a quick fix by sawing off a gear from this side and adding a gear on this side so that it would fit down onto this one down here and go into this one. So now it's actually only dividing the movement by half, which is the same as the y-axis over here. These outside parts here doesn't do anything, but they're nice to look at, so that's fine. Some small things that are a bit funny about the project is, for example, this one. These two gears are actually skewed due to human error while assembling them, and we didn't notice that before we had actually put this on into the box. So that was a huge issue until we actually found another gear that we made that was also skewed. And they more or less negate each other, and there's no actual, friction. So it's very nice to move around. This actually works much better than this one over here, because this one over here has so many more gears that it needs to go through. Other quick funny things could be, for example, this one here. Originally in the design, we wanted to have the other gear here, and this gear over here actually had an issue because this gear over here was so much heavier, because this was one of the smaller ones, so it would actually tilt everything down like this, and it would have issues down here. So we inserted this bolt in order to account for the weight, and it actually works very nice right now, because we have this huge gear and this gear as well on this side, and then this bolt again to account for the weight, because they can tilt a little bit, and it fits very snugly. It's very neatly made. If you can see down here, there's some plastic sticking out. Yes, you can see that, and that was actually an attempt to avoid this issue that we had with the what do you call it, the wiggling, and I was just basically taking some of the plastic sitting on the acrylic plates in the VLab, and then folding it around in order to just fill out that half a millimeter gap. And it sort of worked, but it didn't work well enough that we actually wanted to fix it. Other than that, the case is made by a program called Case Maker, or Maker Case, and that pretty much just, it takes the dimensions as input and makes a fine print for you. That means that you can just, well, the camera is being held there. That fits very, very well onto this one. So that was a really, really good quick fix. We very much recommend the website for anyone who needs to make boxes on the laser cutter.